Hey guys, this is Mr. H again. Hey, I am gonna do another video of the game that I play with my students called finding the inverses and also the order of inverses. So what I do is I spin my little book, it'll land on something. And what I'm supposed to do is I'm supposed to go through and tell me the inverses and also the order that those operations are occurring. So watch. So I'm going to spin this. Well, that one was simple. All right. So for this one, if I said, what's the opposite of x to the 1/5, that would be x to the 5th, right? Those are inverses of each other. If I spin it, let's see, what's the opposite of the cube root of x? It would be x to the 3rd power. Okay, those are inverses. Okay, now, so here, now this one, if I were trying to find the inverse function of this function, I would start by doing PEMDAS. So remember, PEMDAS is parentheses, so I would go to parentheses, and I do have parentheses, so everything inside the parentheses goes first. And within this, since this is kind of a stack fraction, that means that the x minus 4 part goes first, and then the division, right? So the very first thing that I'm doing, let's see, I got it in blue, is I'm subtracting 4 from x. And then I'm dividing by 2. And then I'm raising all of that stuff um, as an exponent, and the base is e. So now if I want to find the inverse, I just reverse the order. So this is going to go first, second, third. And all I'm going to do is I'm going to find the inverse of something with a base of e. So that would be the natural log. Okay, so I'm going to take the natural log first, and then I'm going to multiply by 2 because that's the inverse of dividing by 2. And then the last thing I'm going to do is I'm going to add 4. So if I go down here, I already know that I'm going to have, it's going to be an inverse, and I always start with x. So first thing I'm going to do is I'm going to take the natural log of x, and then I'm going to multiply that times 2. And then I'm going to add 4 to that result. So I'm going to add 4 to that. So this is the inverse of that. Now, I'm going to erase all of this so it doesn't get confusing, but I've already done this question and I use Desmos. So I want to show you what it looks like. So this is the original function, e with base e. Here's my composite function, or my inverse function, g of x, and then look at it. It's 2 times the natural log of x plus 4, which is what we found. And then to check it, I just do the composite of those two functions. And basically, when I take that graph, it should give me the y equals x line, and it does. So whenever I take the composite of two inverses, it should always give me the y equals x line. If it doesn't, that means I've messed up. If it does, then you can feel comfortable, very confident that you found the inverse, and I have. Okay, so let me go back. Let me try a couple more. I'm just sending these back to the original. Uh, get rid of that. All right, now let me spin. All right, here's another one. I think I did this one in the last video, so I'm gonna keep spinning. Let me see. I want another one. Oh, here's one. Now this looks really messy. Like most students will look at this function and go like, whoa, I can't do that. That's too much. But again, start with PEMDAS. Now, one of the things that I would also tell you as a hint, just count the numbers that you see because each number represents an operation. So I've got a 2 here, I've got a 5 here, I've got a 3 here, I've got a 6 here, which is why I have 4 steps over here. Now, again, I want to know, based on PEMDAS, what do we do first? Well, the first thing that we're going to do, here's the x, we're squaring it. So first thing I'm doing is squaring the x. The next thing I'm doing is I'm adding 5 to it. So I add 5 to it. Third thing that I'm doing is all of this stuff is raised to the, it's raised, and 3 is the base. So this is 3, and I take all of that stuff and I raise it. And then the last thing that I'm doing is I'm subtracting 6. Okay, now That's how you kind of pull it apart. Now, to create the inverse function, we're going to put these things back together with its inverses. So I'm going to switch colors. So I'm going to go 1, 2, 3, 4. So I reverse the order, and I'm going to find the inverses. So the inverse of -6 is +6. The inverse of 3, to have an exponential with the base of 3 is to have a log with a base of 3. So that's the inverse. And then the inverse of adding 5 is subtracting 5. And the inverse of squaring something is to take the square root of that. Okay, so now to come up with the inverse function, I'm just going to do these steps in this order. So I'm going to start with, I'm going to make this a different color. I'll use blue. So I always know that I start, because I have x over here. So first thing I'm going to do is I'm going to add 6 to x. And then I'm going to take the log of that with a base 3. So I'm going to take, whoops, I'm going to take the log base 3, and I'm putting it in parentheses to indicate that I'm doing the sum of those two things. And then I'm going to subtract 5 from that. And then I'm going to take the square root of all of that stuff. So I'm going to make this red or black so you can see. I'm taking the square root of everything over here. And so this is the inverse. Now this looks a little messy, but this is generally, I'm not looking at the domain. I'm not restricting domain. Like that's another part that needs to be done, but I just want you to see how the inverse process works. Now, I'm going to get rid of this, and I've done this graph before using Desmos. Now this one is weird, a little weird, but here's the original function. It's green, so that's this part over here. And then here is the inverse function, which is black, which is over here, right? But then when I take the composite of those two functions, I should get the y equals x line. And I do, but it's a little weird. It starts at, what's the domain start at? Looks like it is 240. Looks like the domain starts at 240. Now, there's a reason for that. I didn't really investigate that, but it looks like the domain starts at 240. But this is the y equals x line. But you see there's nothing down here. Now, that's probably because you have to restrict the domain, because otherwise it doesn't make sense. But the thing that you should see is that when we take the composite, it does give us at least part of the y equals x line. So this is fine, but again, we have to restrict the domain because certain numbers, I guess basically what we need to do is this part in here, it has to be greater than or equal to 0, because otherwise this doesn't work. Okay. And it looks like it starts at, looks like x has to be greater than or equal to 240, based on this graph. Now, I haven't actually done the math, but that would be interesting to see if someone can kind of do that and tell me if I'm right or not. The graph is telling me that the domain starts at about 240, but I haven't actually verified that. Okay, should I do one more? Let's see here what I got. What do I have? All right, let's look at this one. Again, we've got 1, 2, 3. We've got 4 numbers, so we're going to need 4 operations. Okay. And now we got to start using PEMDAS. So the very first thing that we're doing to x is we're raising it to the 5th power, and then we subtract 2, and then we multiply by 3, and then we add 7. So to find the inverse, we're just going to reverse the order of those operations, and we're going to take the inverses. So the inverse of adding 7 is subtracting 7. The inverse of multiplying by 3 is dividing by 3. The inverse of subtracting 2 is adding 2. The inverse of raising something to the 5th power is to take the 5th root. Okay, so first thing I'm going to do is I'm going to go here, and this is the inverse function. I know I'm starting with x. So the very first thing I'm going to do is I'm going to subtract 7 from it. Done. Then I'm going to divide that whole thing by 3. Done. And then I'm going to add 2 to that quotient. Done. And then I'm going to take the 5th root of everything. So I'm going to put this whole thing as a 5th root. So boom, that's my inverse. Now, so that's all you're doing. And this, to me, if you understand PEMDAS, and then you also know inverses, most students are pretty good with inverses. They're pretty good with PEMDAS. We're just combining those two processes, and then it's a pretty straightforward thing. Now, I'm going to erase this for just a second, and I graphed this on using Desmos, and I want to show you what it looks like. All right, so here's the original function. It's in red. So it's this red line going here. You can see that. And then the inverse function, which is what I just did. Now notice I wrote it, instead of the 5th root, I wrote it to the 1/5 power, which is the same thing. And so that would be this line. And you can see that they're symmetric to each other. But the telltale sign is I did the composite, and I got the y equals x line. So that's the proof that these two are, in fact, inverses of each other. All right. And that's always, if you, once you have your inverse, if you do a composite and graph it, a graph of those two composition of those two functions, you should get the y equals x line. If you don't, then that means they're not inverses. If you do, you can feel pretty confident that you do have the inverses. All right, I'm going to stop this and I'm going to post it.